Hi, my name is Alex.
Hi, my name is Tyler.
Hi, my name is Noah.
Hello, this is Chauncey's Game of Life, which is a cellular automaton that operates on 4 rules based on Conway's Game of Life. Any live cell with fewer than 2 live neighbors dies as if by underpopulation. Any live cell with 2 or 3 live neighbors lives on to the next generation. Any live cell with more than 3 live neighbors dies as if by overpopulation. Any dead cell with exactly 3 live neighbors becomes a live cell as if by reproduction. The controls are the arrow keys to move the cursor, WASD to move the screen or world, space for pausing and playing, enter for editing the state of a cell, Z and X for zooming, and 1 through 0 keys for BGM selection, and left alt as well. I will show a bit of how this works. So when I press the space bar, the button at the very bottom switches between a play and a pause. If I am to press enter while the game is paused, I can place a cell here. You can see that. I can also use the WASD keys to move the screen or the world. Do that now. If I place some more cells like this, and I press play, you will see a Gosper glider. It will move across the screen in a certain pattern. And when certain when certain conditions are met, the achievements in the lower right corner will be unlocked. We'll also see a pop-up at the bottom of the screen. Now I can pause again at any time. I will now make an acorn, which is the acorn is a Methuselah, a special classification, meaning that it creates a large number of cells over a long time. Now, if I am to press the pause, if I am to play the game, and also I can zoom out a little bit. Give me a second. You can see it creating a pattern right here. That is the acorn. So once all the achievements in the game are collected, or if you press P, you will get this pop-up, and that will indicate that you have completed the game, but there's still more that you can do if you want to. Also, when you are playing the game, you can use the 1 through 0 keys to change the music. When I press 2, 3, 4, 5, 6,
Once upon a time.
7, 8, 9, 0, left alt. That does it for the demo and on the controls.
I was in charge of doing the pause button down at the bottom of the screen, along with the information over here with cycle number, how many are alive, whether the cell that it's on is alive or dead, cursor position and the X and Y coordinates, whether the cell that the cursor is on is going to be alive or dead next time, and the world position, which is manipulated by the WASD and the scale. I also was in charge of making sure this pause button works by either clicking it or pressing the space bar. And then I also was in charge of adding in the music with the keys 1, 2, 3, all the way through 0, and left alt. code for the info window is all right here. It was a lot of captions that used STRs, used string addition with STRs of a lot of different variables and information that was obtained from different areas. And then the pause button was in controller, and that was this was where the pause button was at. It would get where the mouse was whenever it pressed and check if it was in the bounds of the image. Then it was also the image itself was from the control window. That's where the image of the pause and play was, and it would change based on whether the game was paused. Then the music itself was also over in controller, and it was all just if the pressed key was something, you would stop the current background music, redefine the current background music, and then play it, and then reset the time, because over in main, in the while true, it would check at the end of the loop if the time of the background music was greater than the controller's background music's get length when it was subtracted by the controller.current underscore time. It would reset the time and repeat the music. So that's the loop right there for the music. And then while true loop happened, it defines the background music as the Terraria music and played it. And that's what I worked on.
My name is Alex Miranda, and I did the code for several different things, including drawing this grid, drawing the cells in the grid, and applying the rules of the grid to the cells, like so. And then also scrolling. World is the main function, sort of where everything happening to the actual game area takes place. In world, in the init, we create an instance of draw world, which is the function that draws the grid and also the cells on the grid. That is what has the scrolling of the grid through its movement methods, which are called in controller right here. Then in world is where the rules are implemented on the dictionary. So it checks if the game is paused, and if it isn't, then it goes through each cell, counts how many neighbors it has, then applies the rules based on the neighbors. So if it has less than 2 neighbors, it dies. If it has 2 or 3 neighbors and is alive, it stays alive. If it has 3 neighbors and it's dead, it becomes alive. And if it has more than 3 neighbors and it's dead, and it's alive, it becomes dead. And then there's some other methods for drawing and whatnot. And then in game, view, controller, and main, everyone sort of works together to get all their functions together. But things have to be called in certain times, and different variables are created in game, which are then shared to everything else.
I was responsible for the achievement system, getting achievements to update when a certain condition was met. One of the achievements were the number of times that a cell has been born, a number of times the cell has been dead, and the number of cycles that have been passed. There is also another achievement for the number of cells currently alive. You can see the achievements updating in the mini view, which I was also responsible. And if you are to press P, then you are all the achievements immediately. And once you obtain all the achievements, the top achievement will be is 100%, showing that you have game. In achievements, I first began by making the achievement box, getting the stats from the and a bit of logic that will be used. I began by making a list containing the text you display, a condition checking for the when to obtain the achievement, a small image that is displayed when the achievement is obtained, and a variable checking for if the achievement has been unobtained or obtained. That is all placed into a list, and for the smaller images in the mini view, I had to resize all of the images. This was using the Python image library. And then those were all placed in lists where I also had the location in the mini view of each list. Those are placed into a list. The update method just updates all these stats. Check achievement method is responsible for keeping track of if the obtainment for each of the achievements have been. If the achievement has been met and also the achievement has not yet been achieved where this variable is still 0 to prevent it from double checking the same achievement multiple times, it will return the index of the achievement into achievement logic from where it is called. This checks for if an achievement is already being drawn. It will then check if the achievement is being achieved, and if not, it will just be negative again. If it is obtaining something, here where the current achievement is -1, it will set the draw timer to 70, which is just going to display the achievement on the screen for a short amount of time. It will then play a little jingle, and then it will set the state of that achievement to achieved. When the draw time is set to a value greater than 0, it will begin drawing for an amount of time. It will draw the box of the achievement on the bottom of the screen, the achievement icon, and then after a certain amount of time, it will disappear. For the drawing of the achievements, constructs a large border box. It then constructs an inner box. Then it constructs the image. And then it constructs the text. For the mini view, it takes the list of achievements and in their smaller images, and it checks to see if it has been achieved. If it has been achieved, it will show that smaller image in the position on the bottom right. If it has not been achieved, then it will be a black square. When you get all of the achievements, well, this method actually just sets the number of achievements to 12, which is what obtains the final achievement here. Alternatively, you can get all of these achievements to obtain this as well.
I think we should get a 93 because we missed one of the days that the IEP was due, and also because we did not complete all of our optional features because we did not complete our speed up and slow down. The parts that I added that were intellectually challenging were making sure that the mouse was pressed in a certain area of the screen because we had not done that before. And other than that, it was just a lot of trial and error to make things look smooth with all the added like window stuff, captions and all that, and a lot of just repeating the same process so that I could store the music separately and call them at certain moments. So a lot of just same thing, but different for each one.
I believe that we should get an A because we managed to get all of our essential features implemented and only failed to get a few of our intended features implemented. What I found what was unique about the project for me was that I made all the achievement icons and resized some of them for the mini. What I found most challenging was getting the achievement logic function method to work, with making sure that an achievement wasn't already being drawn, checking to see if the achievement had already been obtained, getting the achievement to appear without being drawn over by other things time, and checking for the conditions that needed to be met for the achievement. And I learned how to do the resizing of the images, editing a list with tuples, and I also learned how to edit the list for the checking if a achievement had already been obtained or not.
I think we deserve a 95 on the project, as we met all of our expected requirements for it. All the features we intended to implement, we did. Some of the features that we wanted to implement, we were unable to, though, but those were the optional ones. But for the IEP, we didn't have it finished when it was due, so we did lose the 5%, as the professor had said. What I did to make the project unique was coming up with, was just having this as our idea for the project, and then also coming up with the idea of having it be a infinitely scrollable world so that you wouldn't have to run out of space in the game of life. What I found most challenging to do was, in general, getting the variables to work together. As in Python, you can't have complicated objects be variables that are shared around. Instead, an integer and a Boolean, each copy of it will be different, but with something like a screen, each copy would be the same. And that's something hard to get working right, which caused a lot of problems when doing things like getting the pausing to work or scrolling, as it was hard to tell what was affecting what variables. And then what I learned in this was, for me, really, this whole course was just using it as a refresher in Python. So it's more just relearning, remembering what I had already done in some capacity in previous classes, like editing dictionaries or lists and drawing with Pygame.